All right, so if you are watching this video, congratulations. This is the final lesson in Algebra 2. So you are one lesson away from being finished with my class. And in this lesson, we are going to finish up by talking about a really useful probability concept called a tree diagram. Tree diagrams are really useful tools for organizing more complicated probability questions. If you take AP Stats with me, we will make tons of tree diagrams over the course of the year. If you take I've taken college statistics, probability classes, we still use this same process in those more advanced classes. So it's a really handy thing to know how to do. So let's go ahead and look at our kind of word problem for the video here, and it's over a really high stakes topic, which is my breakfast. Every single day I try to have a nice breakfast. I look forward to it, a little cup of coffee to go with it. It's just great. And for my breakfast, I frequently try my best to make it healthy, but sometimes I slip up and I have something a little less healthy. So on 70% of the time, 70% of days, I have a healthy bowl of cereal for my breakfast. Eat some Cheerios with banana on it. It's just great. But then 30% of the time, I slip up and I have some sort of pastry, like I don't know, something really tasty, and it's just awesome, but I feel a little bad about it afterwards. That's 30% of the time. Now, I've been noticing that I tend to have snacks before lunch, eating extra stuff, more frequently on the pastry days than on the cereal days. When I have cereal, I only have a snack before lunch about 20% of the time. But when I have a pastry, it bumps up all the way to 60% of the time that I'm having a snack. So my question is, what is the probability that I have a snack on a given day? So there's kind of a lot going on in this problem because you have to keep straight, okay, well, what did you have for breakfast? And then, oh, okay, well, did you have a snack or not? There's two different things at play right here. When you've got two events that kind of go in an order like this, like I have to make my breakfast decision before I make my snack decision, a tree diagram can be a really useful thing. So on this next page, I have a summary of all the info on that slide, and I want to show you guys how you make one of these tree diagrams. So what I'm going to do, when I wake up in the morning, my first big decision with respect to this problem is what I'm going to have for breakfast. And according to my problem, I either have cereal or I have a pastry. Those are the two options that I left myself to have. So I'm going to make two branches, starting off my tree right here. I could end up having cereal. So I'll have cereal right here, using my sweet trackpad mouse to write this out, so my handwriting is pretty great. I could also end up deciding that I'm going to have a pastry instead. So what you do is you write down the thing that's happening on the edge of the branch like this. And along the branch itself, you put the probability that goes with it. 70% of the time, so 0.7, I eat cereal. And then 30% of the time, I have a pastry. The little branches like that should always add up to 1, because 1 means 100%. If I eat cereal 70% of the time, it must be pastry the last 30%, unless there's some third option, in which case I'd have 3 branches coming off of it instead of just 2. So you got to make sure your little branches all add up to 1 if you did it correctly. So after I make my decision on cereal or pastry, I'm still either going to decide to have a snack or not have a snack. Even if I have cereal, I might still end up having a snack afterwards. So I'm going to go snack, and I'm going to go no snack. So if I have cereal, I can have a snack or I cannot. If I have a pastry, I can still have a snack or not. So what this tree does is it breaks out like all your little decisions that you can make. I can go cereal with snack, cereal no snack, pastry no snack, and it breaks it up like that. It makes it easier to diagram and visualize. If I have cereal, I'm only going to have a snack 20% of the time because evidently my bowls of cereal must fill me up a little more. And it didn't say my no snack, but it makes sense. If there's a 20% chance I have a snack, it's called the complement. It's just the opposite. That means there's an 80% chance I do not have a snack. So these little branches here have to add up to 1. And if I have a pastry, that means that 60% of the time I'm going to eat a snack. So if I eat a snack 60% of the time, 40% of the time, I must not be having a snack. These probabilities on the second row are what are called conditional probabilities. These guys right here. Conditional probabilities you have to have something else already happen. So I already add my cereal and my pastry, and the probabilities you see circled right here are based on that. So they're based on something that already happened. If you take Intro to Stats with Mr. Spinks or AP Stats with me, you'll do more with conditional probabilities later on and learn a lot more about that. For right now, though, now I have a tree. I'm ready to answer the actual question, and the question said, I want to find the probability that I have a snack. Well, the probability I have a snack could happen in two different ways. It could be that I have a bowl of cereal and then I decide to have a snack. So this is one path in my tree that would lead to me eating a snack. Now I just said the word and when I did this. I have to have cereal and snack. That means you multiply together, and is multiply your probabilities. Generally, I'll put that just on the end right here. A 0.7 times a 0.2 is a 0.14. So there's a 14% probability, if you pick a random day, that it was a day I both had cereal and had a snack. They didn't ask for this one, but if I go to the next one, cereal and no snack, 0.7 times 0.8 is a 0.56. And those two branches together, 0.56 and 0.14, add up to 0.7, which is good because 70% of the time I'm supposed to have cereal. And I just keep multiplying my paths here. 0.3 times 0.6 is a 0.18. And then finally, 0.3 times 0.4 is a 0.12. And means multiply. So my little green probabilities here on the end are each individual path happening. Well, me having a snack could be that circled path up here. So it could be my 0.14. Or it could also be where I had a pastry and a snack right here. Well, that guy is a 0.18. So I said the word or when I did that. It's either this path or it's this one. So you have to add those two things together. 0.14 plus 0.18, because or means add, is going to be a 0.32. So evidently, on a random day, there's about a 32% chance I'm going to have a snack before lunch. Tree diagrams help us organize those different events going on and make it easier to understand. So your assignment, your last assignment ever in Algebra 2, is going to be to make up a word problem similar to mine, draw a tree diagram for it, and then calculate a probability. Use mine as a model. If tree diagrams are still a little iffy, you can definitely email me and I can help you set it up because these can be a little trickier. You basically have to have two things that happen. You have your first thing, and then you have a decision you make based on what already happened in the first place. So use this as a model, work out a tree diagram problem, send it to me, and you guys are officially done with Algebra 2. Have an awesome summer. I've had a great time with you guys this year, and hopefully you've enjoyed my class. Thank you so much.